Hello all. Let's see the difference between interference and diffraction. As a first point, if we see the interference pattern is a result of interaction of light that are coming from multiple sources of light. If we take the say a double slit experiment, the two slits from where we get light will act as a separate source of light, and the interference pattern on the screen is a result of interaction between these two slits. Whereas in diffraction, we have single slit. Let's say in single slit diffraction experiment, a single slit is illuminated by incoming planar wavefront, and the diffraction pattern on the screen is a result of interaction of light that are coming from the same wavefront. And if you see the inference fringe width, it may or may not be of same width. If we take Young's double slit experiment, the fringe width is given by lambda d by small d, where lambda is the wavelength of light and capital D is the distance between the slit and screen, and small d is the distance between the slit. So all these are constant. So the fringe width is constant. Whereas in Newton rings experiment, the radius of nth dark fringe goes like square root of n, and hence the fringe width also should go the same order, square root of n. Hence the fringe width is not constant. In both cases we get interference only. The fringe patterns are arising due to interference of light only. In Young's double slit experiment we have fringe width, constant fringe width, whereas the fringe width is not constant in Newton rings experiment. And in diffraction, if you see the central bright fringe, it is more wider than the first order bright fringe, first order maxima, and first order maxima is more wider than the second order, and it keeps on decreases when you go away from the central maxima. And if you see the regions of minimum intensity in interference are perfectly dark, means this intensity maximum or this bright region is due to the interference of light that are coming from these two slits, whereas the dark region there is no light. These two lights are destructively interfered there, and no lights present there. It is perfectly dark. There is no background light in interference. Whereas in the diffraction, single slit is illuminated by monochromatic light, and there will be always some background light will be there in diffraction, and this minima is not absolute minima. There will be a background light. With respect to that, the maximum will be more brighter than the background minimum light. And as a last point, all bright bands are same intense in interference, whereas in diffraction, the second order maxima, intensity of second order maxima with respect to the central maxima follows this relation, okay, where alpha is a function of theta. So when you increase the theta, means when you go away from the central maximum, the theta increases. If theta increases, alpha increases. So this alpha comes in the denominator. When you increase theta, so the second order maxima with respect to the central maxima keep on decrease.